Alright, some parts on our project circuit board are these chrome boxes are the transformers. There are several of them on there. We have capacitors, the blue and black circles. There's a power transistor right here that's got that heat sink on top of it. Right here there's a amplifier transistor. This chrome oval right here is the oscillating crystal, and this LTW455, that black box, it's a filter, and underneath those popsicle sticks that are holding together that DC motor and the prop is a servo motor, and this right here is the antenna, and obviously that's where it attaches to the circuit board.
Our DC motor is directly connected to the propeller and is powered through the circuit board by a 9.2 volt battery. The DC stands for direct current. The motor is pretty simple in concept and is basically a coil wound around the steel drive shaft that is stuffed in a cylindrical enclosure that has magnets all around it. When supplied power, it spins proportionally to the amount of current. When the coil is powered, a magnetic field is generated around the armature. The left side of the armature is pushed away from the left magnet and drawn toward the right, causing a rotation. The armature continues to rotate to 180 degrees. When the armature becomes horizontally aligned, the commutator reverses the direction of the current through the coil, reversing the magnetic field. The process then repeats. Our servo motor is the large black box on the circuit board with the drilled white circle attached to it. Servos are essentially electrical motors that can be positioned precisely. Ours is told what position to go to by the integrated circuit within its black box after it interprets the pulse codes. Most are designed to move up to 180 degrees of rotation and all have 3 wires, the third being the control wire. A servo pulse of 1.5 microseconds width will set the servo to its neutral position, or 90 degrees. For example, a servo pulse of 1.25 microseconds could set the servo to 0 degrees, and a pulse of 1.75 microseconds could set the servo to 180 degrees. An oscillator crystal is a very precisely sized slice of quartz crystal that vibrates only when a certain frequency hits it. The size determines the frequency it vibrates at. When quartz vibrates from being compressed or bent, it generates a voltage on its surface, known as the piezoelectric effect. This characteristic makes the crystal a precise filter for receiving and transmitting only a certain frequency. In our circuit, both the transmitter and receiver oscillator crystals are sized to oscillate at 27.095 MHz and are what send and receive the pulse codes. There are many different frequencies quartz can be sized to oscillate at, and RC vehicle manufacturers use this to their advantage to allow their vehicles to be capable of operating around others. Nice RC vehicles often have a way to access and change the oscillator crystals in the remotes and receivers. Our donor RC plane is basic and does not allow for this. Electromagnetic radiation is simply a bunch of photons traveling in waves. Waves are produced by the acceleration of charges. They're actually radiated from the photon particles. There are many different wavelengths, different frequencies within the spectrum. These are listed and represented in the picture. All of these travel at the speed of light. Obviously, length and frequency are inversely proportional as shown in the picture. So as frequency increases, its length decreases. Our project was based on PCM of radio waves. PCM, or pulse code modulation, is a digital representation of an analog signal where the magnitude of the signal is sampled regularly at uniform intervals, then quantized to a series of symbols in a numeric, usually binary, code. The transmitter essentially sends out 2 codes, one to say, hey, pay attention, and another of a certain time interval of signal and no signal, saying, now do this. with a specific count of pulses, each for a different task or combo of tasks. In the picture below, the D part is the part saying, hey, pay attention. The E is the now do this, and F is stop.